Patience virtue. All right. So we are going to talk about direct comparison tests versus limit comparison tests. But we're going to start with direct comparison tests. Okay, so I'm going to come up with an example, and the example is going to be, give me a second. So basically, let's talk about what's direct comparison test first. They say if summation of n equal to 1 and infinity, sorry, I have a precondition here. I'm going to tell you this. Let 0 less than a to the n less than b to the n. For all n, if limit of b to the n converges, then summation of n equal to 1, infinite a to the n converge. Does that make sense?
Yes.
Because the bn is less than, yeah. So like for example, if Marco sucks at basketball, Mr. Ye must suck. No question. But if Marco is good at basketball, right? Marco is Michael Jordan, then I'm less than him, but I could be suck or I could be great too. So we are compared to the b to the n. Okay, so that's very, very important. If b to the n is diverge, then it's Michael Jordan. Okay. Don't get me started.
If you're worse than Michael Jordan, you could be bad or you could be good.
You could be good. I could be good.
But then how is A to the N?
Because if B to the N sucks, if Michael Jordan sucks, then you have to suck as well because you're worse than Michael Jordan.
No, he's saying Michael Jordan's really good.
Yeah, if he's really good and you could be bad,
that means it's diverse. So it's not saying if you're gonna be worse than no matter what, but you can be diverge or converge.
Okay, let's talk about this.
Also, if it diverges, then A and can converge.
Yeah.
Okay, so if a to the n diverge, what do you think? No, a to the n.
Oh.
N equal to 1. B to the n must be what? Why? And not just say, okay, so Devin says I have objection. I think LeBron's better. So let's just say Michael is greatest all time or greatest or whatever, second greatest all time, right? So let's just say if he's second greatest all time, he's diverged, right? And if you say LeBron James is even better than Michael Jordan, then he must be also diverged as well. Does that make sense?
Ian's success. Ian's good.
No.
Yes. That's facts.
So what matters is if it's convergent or diverge, not either of them.
I mean, it's the same thing, just different words.
Yeah, I just said good or bad.
Is that okay? You get it? Okay, so what we're gonna do is we're gonna start with some questions. The question we're gonna start with is summation of n equal to 1, infinity 1 over n squared plus 2. Okay? So first thing first, is this greater than 0? It doesn't matter what I plug in. Is this greater than 0? It is, right? Because I plug in, it could be, if I plug in 1, it's gonna be 1/3. If I plug in 2, it's gonna be 1/6. So 1/3, 1/6, and 1/11. And if you adding, so 0 is less than 1/n² plus 2. So this is called bound. It has a lower bound at 0. Now, what? It can be equal to 0, but that doesn't matter. It's always going to be greater. It can equal to 0 in certain situation. We're not talking about this particular series, but other situation. Okay, let's just say other situation has the thing. So because this part, does that make sense? Oh, you're right about that. That should be this. Okay. Now, what happened is, what we're gonna do is we're gonna say, well, the problem is that extra pieces right here, that +2. That +2, ideally, we can have gut feeling this is probably gonna be converged. Just according to our gut feeling is converged, but you have to establish a proof why they are converged. So what's the best thing to compare with? What do we compare with? 1/n². Okay, good. So 1/n², that is get rid of the extra pieces. And if I get rid of the extra pieces, which one's greater? 1/n² plus 2 or 1/n²? Yep, this is a Michael Jordan. No, this is not Michael Jordan. This is
It might not be as.
yeah, that's Marcos. That's Marcos.
And then 1/n² plus 2 is 38.
Yeah. So Marcos here, and this is a Ye. Right. If Marcos suck, Ye suck. So you are compare this. So what we're gonna do is we're not establishing this series, this original series converge or not. We just establish this is compared to the n², n equal to 1, infinity. You have to say what kind of things. On my test, you have to show me. You can answer it feel like converge. Yeah, it's multiple choice. But you have to say due to what? Due to P series. You should have choose P series. Why? Because this is 1/n to the P. And the P is equal to 2, but it's greater than 1. Therefore, it's converge. So, summation of n equal to 1 of infinity 1/n² plus 2 also converge due to direct comparison test.
Is that the one where you take the integral?
No. It's the P series. So if this is greater than 1, it's always converge. If you have 1/n to the P, that's the P series.
Yeah.
That's the easiest one you need to know. Geometrics, P series, those are the cake. Yeah, those are the for sure that you know either they are converge or diverge. Very easy due to the R or due to the P. If R is less than 1, the absolute value R is less than 1 and greater than 0, then it's converge. It's greater than 1, then it's diverge. Okay, so the next question for you. How about this one? You're gonna do this one. You're gonna do this one. But write it correctly. Please learn how to write it correctly so I can give you points. The problem of this is a lot of you guys can have that gut feeling says, oh yeah, this is converge, this is a diverge. And that's going to be your biggest obstacle. You had to prove to me that why it's converge, what's diverge, due to what kind of test. You cannot just say, yeah, it's converge, because I feel like it. And I cannot give you a point, just even I want to. I agree with you. I don't disagree with you. Is everybody here? Yulia is here?
Yes, she is.
Wait, Ilya's not here. Marcos, if you give me that one more noise, it's gonna throw a stable at you.
Steve?
The whole stable.
Yo, I was in preschool and she stapled my finger. She stapling papers and she stapled my finger.
Oh, I thought it was on purpose. I'm like, damn, that's a lawsuit there. Your mom will sue school so fast.
It feels
No, it was on purpose. Yeah.
Anyone would, right?
No, I won't. I'll be a tough it up boy. Stop whining.
I don't think you'd sue them. It's not like...
I told you about a story, right? Of this kid named Christopher.
No, you never told me.
He's always stoned.
And what happened?
So he's stoned so bad that he'll come to me. I was like, Christopher, stop doing drugs, like literally, like. And I would say, Christopher, you need to stop doing drugs. He's like, no, man, I don't do drugs, dude. And he would take the stable, he'll whack on his hand, and he'd be like, look, Mr. Ye, it doesn't even hurt. And the thing started like getting redder and start like related Ray. It's like growing larger and larger. And I'm like, that was an interesting person. Huh?
We had a teacher who would do that in class.
Really?
Yeah.
Maybe he's on drug too.
He had like a bottle of some like painkiller, like the stuff they use in circuses. And he had that and he drank it and then he'd staple his arm. He also had a pet lizard. Like a giant lizard.
That's interesting.
It might have been Mr. Norman.
I'm gonna send my kid there.
Yeah, I think that was his name, Mr. Norman.
There's no way it's not Miller wasn't high.
Zach Miller? Zach Miller's not high. No, he's not high. He's a happy person. Let me think about who's high here. All right. Shh. What do you guys do? Do you guys got converge or diverge? Okay, so what do you compare with? 1/2n. So what is that? Is that P series or this is geometric?
Geometric.
Geometric, because technically you can rewrite this as 1 over 2 to the n, right?
Yep.
So if a summation of n equal to 1 and infinite of 1/2 to the n, since this is geometric and r is less than, absolute value of r is less equal to half is less 1. Oh, it's equal to, sorry, it's equal to. It's equal to 1/2 is less than 1. So therefore, summation of n equal to 1, infinity 1 over 3 plus 2n also converge. Due to direct comparison test. I'm going to write down shorthand, direct comparison test, DCT, because I'm lazy. Oh, most of the calc teacher are lazy.
So like an exponential growth. That's exponential growth. I mean, you're like population, so it's growing.
Imagine 2 plus 4 plus 8 plus 16. Is that going to be finite number? Yeah, let's go to infinite. But it's 2 plus 1 plus 1/2 plus 1/4. Yeah, so the r is less than 1. Okay, the next one's kind of challenging. So you guys will be ready. N equal to 3. Infinity. 3 to the n. 2 to the n minus 4. Why is n star at 3? Why is n star at 3? If it's 2, it's undefined. Good. And if it's a 1, then it's negative. But you want the bounded at 0. Does that make sense? Is everybody okay for the last question, Carol? Armin, you guys okay on that side? Yeah. Brenner, is it okay? The last question. Last question, don't understand? Nathan, you doing okay? Robo, Zayden?
Yeah.
Good, good. Do you guys diverge or converge here? You gotta provide a justification though.
This is r is greater than 9.
So the n doesn't matter, right? The initial n.
You can start
And you can
anywhere.
start, yeah, when you do the like geometric, if you said, oh, at n equals 3, doesn't matter. N equals 1.
Okay, so what we're gonna do is we're gonna compare. So 0 is less than 3n over 2n minus 4. Now, what do we compare with? What do we compare with?
3n
3n
over 2n.
over 2n. Okay, which one's bigger though?
The left.
Oh, right.
Yes.
Because you're subtracting the denominator.
That is bigger, especially n is greater than 1. Or greater than 3, sorry. N is a start on 3, right? you adding something and you subtract something, you make it denominator smaller, you make it the numerator greater. Does that make sense? If you don't, your denominator stay as a bigger number. If you reduce your denominator, your whole the whole fraction is gonna be bigger. Does that make sense? Okay, so this one is bigger than this. Is that okay? So then we're gonna say, well, what is summation of 3 to the n over 2 to the n? N equal to 1. N equal to 3, sorry, this is 3. It doesn't matter here, but this is infinity. If this, you're gonna say 3 over 2 is bigger, so absolute value r is equal to 3 over 2 is bigger than 1, so it's diverge. Now, if this is diverge, this is the Michael Jordan, and you can say this is gonna be LeBron James. It's bigger than Michael Jordan. Whatever. I don't agree with that, but I'm just saying for instance. If 3n over 2 to the n, Devin, is 3n over 2 to the n is diverge. And this here, which is the series that's asking, is bigger than diverge. So this must also diverge as well. Because it's bigger than diverge. Is that okay? Now, is there any other way to prove this divergent? Any other suggestion that you can say this is also diverge? It's any other test that you can do that is also diverge. I want integral that. That's gross.
Can you say divergent?
Huh? Can you go what?
No, you can't.
Yeah, you
You could
do what? You gotta say it.
the diverge. This is the test where like
The
approach.
test for divergent, end-term divergence test. So can I do limits? Can I do this one instead of limit comparison test? Yeah, of course. Actually, matter of fact,
Isn't that like the first thing you should do always?
yeah, that's the first thing. That's like a flame test on chemistry. That's the first thing you should do if you want to test the unknown. Flame test.
Okay. That's why you did it, but I-
Those of you guys in AP Chem, you should know this. Flame test. Okay. So just so you know, if you go to UF, if you go to chemistry, actually any kind of chemistry department, they're gonna give you a vial. Your test is a vial. And you're gonna take that vial, you're gonna find out what is the chemical compound in there. That's called, you want to test for unknown. So you have to do a series of tests. The first test you should do is always a flame test. You take a stick, dip on it, burn it. If it show up green, there's copper in there.
Oh, okay, we did that.
If it show up as a,
Different signature color.
yeah, so the most obvious color is green. So if you have tested green, you are in luck. You are like 30% of your grades there. But most of the time it's not copper. Well, if it's copper, they will give you some harder ones. It'll be probably copper nitrate, because nitrate test is really hard to do. Or chloride test is really hard to do. So there's some test called nitrate test or chloride test. Yeah, I was a chemistry major for. I have chemistry degree actually.
Somehow.
What do you mean, some remember that? Yeah.
You need to leave me alone.
Yeah, I was not aware.
Okay, so in UF you can fail really easily if you didn't come up with the right compound. So they will give you all the chemical that you can do. So do you know how to test for chloride?
I'm not a chemist. What? Why would we know that? How would we know that? This is a calculus class.
Huh? No. If you want to test it for chloride, you want to use your solution to mix with silver nitrate. The reason why silver nitrate is gonna form participate with
Yeah, that's a,
it's called silver chloride. It's gonna form a brownish precipitation. I don't remember exactly what color, but it's gonna form precipitations. So like or lead chloride is also gonna form precipitation. So you can do lead nitrate, and you can mix the combination. So you have to decide. That's why I say college classes are much better than AP classes.
that's the problem. No, but you have to find amount to find the compound. You need more mass to find the compound.
Now, of course, you have to do L-Hopto rule here. So it's gonna be and sorry, got you guys distracted, but if you do L-Hopto rule here, you can take out the ln3 over ln2, and then that's gonna be 3 over 2 to the n, limit n approach infinity. This will not equal to 0. If it's not equal to 0, it's automatic divergent. So your first test, you should always think about n-term divergent test because it's very easy. You don't have to compare with nothing, and you're done.
Wait, didn't it?
Yeah, we show you second way to prove that that's divergent.
But the first part, if you just like plug in infinity, doesn't that already not equal 0, so it's divergent?
Yeah, you can do that, but you can actually take L-Hopto rule to show you because infinity over infinity. Infinity over infinity is indeterminate.
But I thought like infinity, the top infinity is like that's better.
But you can't explain it like that.
You
can't
can't?
say, oh, it's bigger, so it's gonna.
Infinity.
Yeah, idea go with gut. That's gonna be it's bigger, so it's good. But the problem is you have to prove mathematically. So I will do L-Hopto rule top and bottom.
It's being FR.
I don't know what kind of test question. I don't know.
Oh, I'm saying like on the exam.
Okay, is this diverge or converge?
Oh. You said the bronze. Easy. And then first.
The problem of this one. Do you see the problem already or no?
Yes.
What kind of problem you have?
Diverge, but it doesn't really tell anything
That
about the
doesn't,
other.
you said
equation.
it doesn't tell you if it's
It
not.
could be like
I could
bad
be
or good.
yeah, I could be as good as Michael Jordan or terrible.
Yeah, so
Pass it.
I am less than Michael Jordan. But Mr. Ye is less than Michael Jordan, of course. But you don't know. Mr. Ye might be great.
Oh, yeah, I got it.
Yeah, what happened?
So,
Daniel, you're not even in my class.
I think that's next.
I'm just kidding. I'm just kidding. Go.
So I think so. You have to combine like the two tests, right?
Which two tests?
We use the comparison, right? And then okay, you get diverge. So he either has to converge or diverge, and then you do the limit test. Then you get 0.
No. We haven't used lemon test yet. Oh, n-term divergent? N-term divergent test?
Yeah. And then you get the limit test, and Actually,
Wait, is it like
Can't you do the exponent? Isn't it n to the 1/2?
But it
Wait, wait, wait,
it
wait.
converts to 0.
Can't you do n to the 1/2 is less than
Oh.
1, so it diverges? Is the exponent?
but it's not funny.
What do you mean?
So here's a problem, right? Here's a problem. You got 0 is less than 1 over square root n plus 1, and is less than 1 square root n. This is true, right? This is true because this one is going to be smaller than 1 over square root n. But the problem is this. The problem is you say, okay, well, this, if you have summation of 1 over square root n of n equal to 1 to infinity, this one is same thing as n to the 1/2 power, right? Now, is that diverge or converge? This is diverge due to what?
This, yeah.
P series. Okay, P series. So P series, because P is less than half, or less than 1, sorry. So this is diverge. But the problem is, this diverge doesn't tell me anything about this. Because I'm less than Michael Jordan, but I could be me, or I could be Kobe Bryant. You don't know. Right? Because Kobe Bryant is still great. Does that make sense? So this is inconclusive test. Inconclusive doesn't mean is you don't know. So we gotta find a better test. Now,
But if you know that one diverges, how is it inconclusive?
what?
That diverges, so then how is it inconclusive?
But that's not what we're looking at.
showed at the beginning is not this.
What happened to the thing where you do the n plus 1? Or you can't do that anymore.
That's only test monotonic. So there was two ways to accomplish this. I may introduce your next idea. Is that okay? So the next idea is called limit comparison test. How much time I have? Okay, that's enough. Limit comparison test says, suppose a to the n is greater than 0, b to the n is greater than 0. And if I put limits n approach infinity of a to the n over b to the n is equal to a L, is equal to some type of number. It doesn't have to equal to 0, it could equal to this number. If it's equal to a number, could be any number, right? L is a finite and positive. So where L is finite and positive, so 2. Let's pick 2. Then the 2 series summation of a to the n and the summation of b to the n, either both diverge or both converge. Sort of, but now we seriously get into limit comparison test. So you compare, you still compare two series, but you put in a ratio to each other. If the ratio come up to be finite, which kind of makes sense because ratio come up to be finite. If it's finite, then guess what? It's either both converge or both diverge.
Should be 0.
Can ratio be 0? We're going to talk about that later. But right now, we're going to try to just not to think about 0 for a second. But they say finite and positive. So Yeah, finite and positive. So what happened?
Why can't it be converge and diverge? Everybody explain that.
They both diverge or both converge?
Why can't it be converge and diverge?
Because that's equal to L. Otherwise, it's gonna be equal to infinite or equal to 0.
Oh, either infinite or zero. Okay, yeah.
Yeah.
I get it.
But if it's equal to a number that's positive, right? If it's a number that's positive, hey, guess what? You're gonna have a comparison. So now what we're gonna do is we're gonna do that. But we're also gonna do a comparison test for the same thing. So now, what we're gonna do is we're gonna summation of n equal to 1, infinite 1 over square root n plus 1. And we know comparison test does not work with this situation because 0 less than 1 over square root n plus 1 compared to 1 over square root n. This DCT does not work. Does not work. Does not work. So we're going to turn to LCT. LCT is just basically put one ratio over another. How do I do that? I'm going to say limits as n approach infinity 1 over square root n plus 1 over 1 over square root n. Is that okay? I put one thing on top of each other. I'm going to see, are they going to reach a finite positive value or not? Finite positive, remember, finite positive. So I'm going to say limit n approach infinity of 1 over square root n plus 1 times square root n over 1. Does that make sense? Keep, change, flip. Limit n approach infinity of square root n over square root n plus 1 are divided by highest degree of the denominator. What is highest degree of denominator? 1/2. So it'll be square root n over square root n over square root n over square root n plus 1 over square root n. In Calc 1, we did this. I told you guys have to show work. You guys say, no, the answer is 0. No. Oh, answer is 1. So limits n approach infinity. This is going to be 1. This is going to be 1. So it'll be 1 over 1 plus over square root n. What happened when n approach infinity? This part is going to go 0, and this is equal to 1. So now it's a positive finite. So we can go by this now, because since 1 over square root n, that's equal to diverge due to P series LCT proof limit n equal to 1 infinity of 1 over square root n plus 1. It's also diverge. Also diverge. Am I going too fast? No? Now you say this is a positive finite. It has to be positive finite. It has to be 1, 2, 3, 4, 5, 6. It doesn't matter. It could be 100. It doesn't matter. Okay? So long as that's true, then it's true.
Okay, so you always have to do the direct comparison test before limit comparison test.
That's the idea. That's the flow chart. Yeah, I would do DCT before LCT, but LCT is gonna be the one that's more complex. So 2n squared plus n over square root of 4n to the 7 plus 3. Now this one's disgusting, right? This one is for sure direct comparison test does not work. Okay. So always pay attention to n behavior, which is you look at n behavior, you look at the largest degrees of the numerator and denominator. Where is that? Yeah. So we only look at end behavior. End behavior, which is the largest term. End behavior is one of the things to decide the function is going to go infinite or it's going to go 0. So we're looking at that. So can we simplify that? Can we simplify that? 7/2, right? Square root of 4 is 2.
Wait, what does it say of end behavior? What does it say?
Okay, how about this? I'll write it again.
What does it say? Lost of end behavior? What does it say?
Look at the end behavior. End behavior is the highest degree because they decide what happened at the end. Because x to the first is not comparison to x to the third. X third is going to be decide what happened when limit x approach infinity. X is nothing. X to the q is bigger. So if you simplify this, what would it be?
1/n to the 3.
Yeah. So can you do the limit comparison test here, from here? Now is this, wait, is 1/n to the 3/2 converge or diverge? Converge due to p series. So p is greater than 1. Okay, so can I do this? 2n squared plus n over square root of 4n to the 7 plus 3 divided by 1/n to the 3/2. I compare two things. Is that okay? Now it's just algebra. Can I distribute that? Two n to the 2 for 7/2 plus n to the 5/2. Is that okay? Square root of 4 n to the 7 plus 3. What is highest degree of the denominator? 7/2. So I'm gonna divide it by top and bottom by n to the 7/2. I'm just gonna be lazy. I'm gonna squeeze in like this. Is that okay?
If it's in the it just be divided by 7. That's
Yeah,
not bad.
inside.
Because it's in the
What? But I didn't put it inside. I put it outside, right? Fine. We can do that. We can do this as a 7. Is that okay? N to the 7.
Oh, the 7?
If you want to extend this square root down here,
Oh, this is 7 all along?
n to the 7. If you want to extend that square root all the way down the bottom. What are they equal to? What are they equal to eventually? This is what? 0. This is what? 0. This is what? 2. This one's what? 2. So 2/2 is equal to 1. So is this converge or diverge? Due to what test? Limit comparison test. Yes, I want to every time. Yeah, but it's due to limit comparison test to compare to the p series. But your test that you're using is the thing.
Compare the highest degree.
Yeah, highest degree. That'll be a good choice.
Why did you look at behavior?
Because that's the largest thing. So for example, if I have something go to infinite, right? If you have x cubed plus x, does the x matter? Or infinity to the cube matter? Yeah, so the highest degree is the one that decided end behavior.
And then you
did that to your son? I think it's true.
She was here first.
Okay.
It's because she's white, not
So, lots of
and also she's surgery.
there is a couple. We've got one, right?
What?
We've got here one.
Yeah.
And we got also here one. What is this one mean? Because here it's saying that it's converged, and here it's saying that it's diverged.
Because you compare with this one compared to one. This is diverse series. So remember, if they both, if L is finite and positive, so this is equal to 1. Now, one that we compare is diverge. So therefore, this one also diverge because they can both either diverge or they both converge. So they have to both exactly same.
So that's why it's one, because like they both the same.
They're both the ratio is not to be 1.
What would make it converge?
What will make converge depends on the series you compare. So the second one we compare with 1 over n to the 3 over 2. That's a converged series. So since this use lemon comparison test go into finite and positive. If it's finite and positive, then they both converge because due to the things that you compare with.
But what I don't understand is, for this example down here, I thought if this diverges, then why doesn't the whole thing diverge? Because up here, it's
Because we compare with this one. If okay, so
so I don't get.
so
same
the thing is,
here.
so and the thing is this. I just say for example, a Michael Jordan situation.
Okay.
So you compare with Michael Jordan.
Mm-hmm.
Like me compared to Michael Jordan. If Michael Jordan divided by me, his skill is infinite amount times better than me, right?
Yeah.
Let's just say he's compete with that's the Michael Jordan and compare with so Michael Jordan's diverge series. Okay, so Michael Jordan, compare Michael Jordan and maybe I mean Kobe Bryant. So Michael Jordan over Kobe Bryant maybe is like 1.12, maybe 4%, maybe 5%. It's a 5% better. Then that means Kobe Bryant and Michael Jordan are very similar. So that means Kobe Bryant is also diverse. So if we can come up a factor of L, positive and things L, then that's true. Now let's just say if I compare me and Reebok, okay?
Yes.
And let's just say I don't know who's better in basketball. I don't know.
Can I go to Mr. Parati's booth?
Yeah. And let's just say he is. If I divided by him, I'm a little bit better than him. But if I suck, then he must also mean he suck. So the thing is, the series is not because it becomes 1. It becomes 1. They either both diverge or both converge. You're comparing with.
But how do you know if it's inconclusive though? Like if you
Oh,
have a
for
problem.
originally
Yeah,
for
yeah, yeah. That's
DCT,
what I'm talking
for
about.
DCT is
That's why I didn't
inconclusive
That's why I didn't understand.
because this one is diverge.
Yeah.
I just
so
say
then-
Michael Jordan, right?
okay, so then the whole-
I'm less than Michael Jordan.
okay.
But if I'm less than Michael Jordan, I could be Kobe Bryant.
Isn't that the same thing as what we did down up
No,
here?
no, it's not the same thing because this is a Michael Jordan part. This one is just say I'm less than Michael Jordan. So I could be Marcos, or I could be Kobe Bryant, or I could be Mr. Ye because all three of us, we suck compared to Michael Jordan. We are less than Michael Jordan. But doesn't mean, what if it's Kobe Bryant? If it's Kobe Bryant, this could be also diverge. In this case, this is also diverge. But it could be like, if this is Michael Jordan, this is me. Yeah, I'm less than Michael Jordan, of course.
Okay.
But does that mean I'm diverge or converge? I could be both. It's inconclusive because it could be both.
Okay.
Let's just say,
But this one, for example, this one here, right?
let's just say
Like-
this is a Shreya. Let's just say this is Shreya.
Yeah. Okay.
And let's just say you're less than Shreya. If you're less than Shreya or whatever, right? if Shreya sucks, you also suck. But it could be a 3-year-old. But not just say nothing. Let's say this is Serena Williams.
Okay.
Okay, and that's you.
Yeah. Okay. There we go.
Okay, so you're less than Serena Williams,
Okay. Yeah.
but you're no way great player.
Okay.
But you could be possible. But what if we compare you, compete Serena Williams, and I don't know, Osaka?
Okay.
So it could be diverge, could be converge,
Okay.
because inconclusive.
Okay.
Does that make sense?
Yeah. That makes it. Yeah.
It sometimes still doesn't make sense.
I think I just have to do more problems.
How'd I do?
Oh no, I didn't grade it. Tomorrow you guys gonna grade it. I'm not
You
grading
have
this.
homework?
Yeah. We have a lot of homework.
I think it's to do the practice just to see.
She doesn't care. Right? You don't think so?
We're not like dropping this fast, right?
No,
Where's Austin?
He's doing karate. I swear he was doing karate.
What happened?
He almost on the board and went to drop out.
No, it's not that bad. It's pretty easy, right?
Yeah, it looks crazy, but
It make. But I do see what's Rebov saying. Rebov's like, I can't really compare with Daniel, Jared, and Anthony. It's like he feels really awkward in this class. Rebov's a smart kid, but he has so much distraction.
back in Wendy Ridge, man, he was good in Wendy Ridge. He was more like the sweat.
Remember the first few weeks of AB, I destroyed him. I keep on going after him.
That was like crazy. It was like, that year was crazy.
Honestly, last year 7th period, I think that it's gonna be like 25% pass rate. Honestly, last year.
Bro.
I was like, nobody's gonna pass this class.
Hey, we all did that. Hey, we all did that.
Everybody did.
That was crazy.
Even Nicholas, even Mason. I was like, well.
We had a crazy class.
Honestly, beginning of the year, if you told me like there's a 50% pass rate, I was like, oh yeah, that's about right.
Yeah.
No, for water polo, because we don't have that many people on the team. Like a few years ago, most of our team, at least 11 kids, seniors, and a bunch of stuff.
Like my freshman year, I dropped in all of us.
No way. Is that like the team captain?
Like,
Okay.
Callie, can you help me?
Running away 2 years.
Sorry. I don't have VPN, otherwise I'll do it. Actually, can you download VPN? So that'll be easier because I want to depend on people.
Yeah.
Yeah.
I don't even know how to use VPN.
Okay, I got you.
You just
Okay.
press the buttons.
Wait, I don't even know my own password.
No.
Oh. This is like the one time I taught you how to tag people on Instagram.
definitely block.
Signal.
Dude, karate is actually.
You used to have it. Download it.
It's like not even here.
Let me see if I remember the password. Oh, I don't need a password.
Oh.
Yeah. Oh, I downloaded before.
Yeah.
Good guys.
Agree.
I just don't
I'm
know how to
ready.
follow my mission.
Don't allow. Wait, allow or don't allow?
Dependent. Yeah, I'm still dependent.
Let me
My
see.
parents,
Wait, why I had to pay?
No, you don't.
do anything by myself.
Anyway.
Well, we were on my flight during winter break, right? We're going to South Bend, Indiana, okay? Middle of nowhere. We're walking up the plane and I see Mr. Prime. He's going on. Yeah, he was on our the plane with us. Yeah.
So whenever you need to turn it off, and then
Because that, I mean, that's
You
my
can
business.
pick up-
I'm trying to
to turn it off,
which is
you
crazy.
should turn it off when you get back home.
We had to
You
go
just,
to a special.
because it'll like
Yeah, only
mess
applies
with
to, like,
the internet.
random
Because your
things.
internet's fine at home, so like just turn it
Yeah.
off when you're at
It's
home.
gonna mess the internet on
No,
my.
no.
I cannot afford to mess the internet at home.
No, you're not messing up anything. It's like
We're just
it's
like-
just gonna be slower.
we're just- we're just-
Like, cause your Wi-Fi's already
It's like
fast
two
at
people,
home, so you don't need to do that.
So I can post right now?
Yeah,
Just
you
to
should
see
be able to.
Let me try it.
Going to the same place, same flight.
Yo, vote me. Let's blow up senior super.
Boy.
Yeah, I did drop. I got you.
Man,
You, Nathan, everybody was standing outside.
Oh, yeah.
Alright, don't be mad just because you ain't got shit.
What about Sean?
Like I'm just saying, like we have the superlative, like
Oh, I can post. Super powerful. Thank you.
I think I deserve it.
Okay, that's all you had to
But you
say.
don't
Like,
gotta
you can't
hate, you
no
know what I'm
problem.
saying?
I'm not hating. I was just like, bro, all you guys are posting.
Man, all you guys just been like calm down.
You're like coming for me at the same
I'm
time.
not coming for anyone.
All right, all right, all right, all right, all right.
Necessary.
You did too.
Yeah, in retaliation, you know what I'm saying? Like,
All right, I got Austin's not here. Austin, stop being lazy. Come to school.
Are you streaming?
Yeah.
What are you doing?
if you go, it's okay.
Okay, shush. Thank you. We are learning two things. We are learning direct comparison tests. So I'm gonna fast. I already posted homework. Then make direct comparison test. And we're gonna say let 0 less than a to the n less than b to the n. For all n. No, we didn't do this. Or Daniel did.
What should you do? My assignment. Recycling.
The topic you're just supposed to be in.
Not just be here, bro. Is that warrants? Is it that easy?
Wait, is that the ACE class?
Yeah, psychology is
But we
so
literally
good.
had to like just write like acronyms, bro.
Dude, anytime I get 100 on a test in that class, my grade goes down because of how much extra credit there is.
AP psychology was super easy too, so I imagine ACE.
So ACE is easier than AP?
Yeah. Like,
Can I take ACE Calc BC?
but even our teacher, like she's bored too. Like she told us all we could do this easily in the semester, but she just put the whole class, but she just put in like filler stuff like this. Like a whole day.
EVA purge is so easy, bro.
This is not filler. What are you trying to say?
No,
We're talking about.
Oh.
No, he said this and he showed up an assignment. Like physical one.
Okay, so this is a direct comparison test. So what we're gonna do, we're gonna start with learning this and the limit comparison test. So we're gonna show you different color limits comparison test. So it should make sense that I just want to make sure I'm recording. It should make sense if Bn is greater than An. So Rebuff, I need you to focus. Bn is greater than An. If Bn converge, that we are assuming the series of Bn converge, then An must converge as well. Is that okay for everybody here? Yes or no, Rebuff? Are you sure? Are you sure? No, I'd rather explain to you.
I think it's fine. That's good.
Okay, so let's just say if you suck at basketball and I'm worse than you, I must also suck as well. Is that okay? So suck means converge. Michael Jordan's diverge. Got it?
Yeah, because Michael Jordan experience.
Yes. It's not LeBron James.
I don't know. Yeah, no, it's- I don't know.
but not yet.
Exactly. That's what I'm trying to say the whole time. Trying to say that the whole time. He's a convergent, not diverge. He just flop.
Look, we should have an Olympics. Yeah, Olympic games with like no like drug rules, so they can just go crazy. Let's see what the actual human limit is. Like real competition.
Oh my god, that's actually so genius.
I know. Thank you.
How much money would it take to organize such a thing?
All right. So okay. So if AN is diverge, now be careful. If but AN is less than BN. So if summation of AN is diverge, BN has to be diverge because you are bigger than one diverge. So you're the greatest player of all time, and you are better than greatest player. Let's just say I'm better than Michael Jordan, right? Hypothetically, of course. Yeah. So I had to be diverge. There's no way I'm not diverge if I'm better than Michael Jordan. Is that okay? Yeah. Okay. So now what we're gonna do is we're gonna do the first question regarding to this. So the first question that we're gonna do is it's called comparison test.
Wait. Which one is diverge and which one is converge? Like diverge is into 0?
Infinity.
Oh, okay.
Diverge is into infinite.
Converge is like a
Like converge into something, it's going to a value. Diverge is keep on going up. Okay. So with that being said, we're gonna first do the first problem, which is summation of n equal to 1, infinity 1 over n squared plus 2. Now this one looks very familiar, but it's not. You cannot say this one is 1 over n squared. It's different than 1 over n squared. However, it can be comparable. So that means you can compare it with it. And not only that, you can compare with, you know that this term is always greater than 0. That has to be one of the requirements because they are greater than 0, because it doesn't matter which n I plug in, it's always greater than 0. Now, we are going to compare with this brown color, which is 1 over n squared, because that's the closest thing that is. Because we know this is the extra information. What does this extra information do to the series? We don't know. So we don't know what happened here. So therefore, we compare with this, and we say, hey, 1 over n squared is always greater than or less than 1 over n squared plus 2. It's always greater than. So good. So that's good idea. So knowing that is very, very important. Now all we're gonna do is establish the proof. We can say, well, summation of n equal to 1 to infinite of 1 over n squared is equal to converge or diverge. Reebok is converge or diverge.
Converge.
Why?
Because it like goes into 0.
Not
It gets smaller and smaller.
well. You had to tell me which kind of series this.
Telescope.
No, that's a
It's P? Yo! I only know the 2.
it's a P series. So P is greater than 1 because I here is equal to 2, but it's greater than 1. So P is greater than 1, it must be converge. So therefore, due to direct comparison test, you have to write it down which kind of test you did. Due to comparison test, if this is converged, this also have to be converged because they are less than that. And this is what you're supposed to write on your test in order for me to give you credit. Like I said, you cannot go with your gut. Says, I feel like this converge. I feel like this diverge. I cannot give you credit for that. I'm going to tell you right now, I'm gonna give you 0 credit because that's that's like true false question.
So is this kind of like a FRQ kind of question, or you just want us to do that?
For me, I will give you like a FRQ question. Now for FRQ on the AP exam, they do have this part. And they do have MCQ as well. So they have both. MCQ, you don't have to show work. FRQ, you do. Unfortunately. Not me, I don't set up the rule. All right, so is that okay? Okay, so you guys gonna do a couple problems for me? So first problem you're gonna do is n equal to 1, and this is infinite, and this is equal to 3 plus 2n. And you have to write on this phrase here because you compare with what? What do you compare with? And is that diverge or converge? Therefore, this one is converge or diverge due to what?
2 to the n.
Yeah, 1 over 3 plus 2 to the n.
Yep, I'm just saying.
Mm.
So I understand that, like the top one, n squared plus 2, and then just 1 over n squared is bigger. What if you just did something that, like, what if you just say just n instead of 1 over n squared?
1 over n?
No, literally just n. Like, what makes you have to do 1 over n squared and not just? Do you understand?
But if it's an n, then it's gonna be diverge.
So and then
Because
but then could you use the limit comparison, and with that solve it? Or I don't know.
no, then you will
No,
equal
because
to
that'd be both wrong.
you're equal to 0 or infinite.
I don't know. I was just thinking, like, why does it have to be that much?
Because you want to get as close as possible. You cannot use some things that it's very far away. So you compare to the closest species as you can. And if that's converge or diverge, you know, if that's less than that, it's not gonna be too far less,
Yeah.
right? So in this case, it's only denominator by 2.
I have a question. It's like unrelated. If you have a number to a certain power, if that power was to the number, would it be the same answer? Like 2 to the 4, same as 4 to the 2.
2 to the 4.
Yeah, because isn't that
4 squared, sometimes it can be equal, but not all the time. At this case, it's equal. 2 to the 4, 4 to the 2, that's one of the equal. But 3 to the 4, 4 to the 3 are different. That's only one weird instance. So it's like 2 times 2 and 2 squared is equal to each other.
I would have done like the math to see if it was, but I didn't.
Okay. That's fair. I thought it was gonna be like something out of the math question. I was like gonna just reject you right away, but it wasn't. It was still a valid math question. Okay, so is this diverge or converge? Converge, good. Because you compare to 3 plus 2n, and this one is gonna be less than 1 over 2 to the n. Because if you added 3 here, let's say 4. 4 adding 3 is 7. So 1 over 7 is less than 1 over 4. Because when denominator gets greater, you actually reduce a number. Does that make sense? So therefore, all I gotta do is prove that this is diverge or converge, which is we don't know, of 1 over 2 to the n. If in this case 2 to the n is gonna be converge due to p series, not p series, sorry, is due to geometric. Yeah. So summation 1 over 2 to the n.
Mr. Yu, on the test, will we have to remember which series it is? Like, if I just do the math myself, like n equals 1, 2, 3, 4, and then I write it out.
No, I cannot take that.
So
I have to.
say-
You have to tell me like what kind of test.
No, I'll say the test. It's just like, do I have to mention P series?
You do. You do.
Oh,
If I did an integral test, does that work?
Integral test. Can it work? 1 over 2 to the n. 1 over 2 to the x. Yeah, you can take an integral of that. Yeah, but that's too much complicated. I mean, unless you really want to do a different part of the test. But yeah, integral test will work. 1 over 2 to the x is 2 to the negative x. So it'd be integral of 2 to the negative x, which is impossible. That's fine. But geometric is way easier because you're gonna say geometric because the r value is less than 1. Absolute value r is less than 1 because this is 1/2. So if it's less than 1/2, it's geometric.
are those the only 3? Telescope, P, geometric. Is there any more?
Yeah, they are.
How many?
So P series, right, that we know is 1 over n to the p. If p is greater than 1, it's converge. I'm going to write it out for you. P is less than 1 is diverge. Less than equal to 1. There is a harmonic, which is related P series. A harmonic series is always diverge. Always diverge. There is a geometric. Geometric is a and a1 summation. I need to write down summation on all of them. So summation a1 r to the m minus 1. If r is greater than 1 or equal to 1, it's diverge. If r is less than 1, then it's converge.
Limit. Alright, that's the sum.
Yeah.
A to the I.
N equal to 1 infinity, n equal to 1 infinity.
It's A to the 1 or A to
N to the
R?
1. N equal to 1.
Equal.
Yeah, r to the n here. This is r. There is a telescope. So telescope usually is going to be summation of 2 fractions. They will go to infinite. That one's the hardest one to tell. Also least likely to test, but it's actually not a hard question. And the last one is called Earned-Term. This is a test. Earned-Term divergent test. And usually I will test this one first because just do limits as n approach infinity of a to the n is not equal to 0, then it's automatically diverge. But does not tell you the function converge or converge or not. It's only tell you if it's diverge for sure. Like diverge for sure or not diverge. It's diverge for sure, that's it. It doesn't tell you anything else. It doesn't tell you whether they are converge or diverge. It could be both. Like 1 over n harmonic is kind of both. Because you use divergent test, you're going to find out n is approaching 0. Is approaching 0? We don't know. We know it's a possible converge and possible diverge. But it doesn't tell me anything else. So
Telescope is that's the one where it's like 2 fractions.
yeah, 2 fractions subtract each other, and there's only 1 term left over. And or sometimes you have to decompose. You have to decompose.
Never mind.
Okay.
I'll do it later.
Yeah, you can ask me other question later, but we're gonna go through a whole lesson first and let you start with the homework. So example, how about this one? N equal to 3 to the infinite of 3 to the n over 2 to the n minus 4. So is this a diverge or converge? And why? Now remember, even though this is a direct comparison test, there's a lot of small things happen. So you gotta be cautious of those things.
code? Can you decompose it?
No, you cannot decompose unless it's factorable on the bottom. 2 to the n minus 4 is not. Wait, can they factorable? They can factor, but just gonna be kind of weird. So will be 2 to the half n minus 2 to the half n. No, square root 2.
Or
Hey,
no,
wait,
n-
no. 2 to the
or-
2 to the half n plus 2 to the half n minus 2. But it's we are talking about, we had to talk about is regular polynomial on denominator, not with the exponents. So this is not factorable. I mean, it's factorable, but it's not in like decomposition ways. So this is diverge or converge, and what do you think? Why is diverge?
There's a 3 on the top. I don't know about the test.
Well, let's strictly, like, you can only use comparison tests. What would you want to compare with?
Say 3 to the n.
Yeah, so this is what becomes tricky, right? So you know that is 0 less than 3 to the, and also why do they start at 3, right? This is also a very important question to ask sometimes. Now, the reason why I start at 3, because if it's 2, then it's going to be 0. As a 1, it's going to be negative. We want to say this lower bound has to be 0. You don't want to be negative. And also that you don't want a denominator equal to 0, so that's not a good choice. So we're going to start n equal to 3, and that's a good choice. So 2 to the n minus 4. Now, you are compared to 3n, so I'm going to use a different color here. You compare this with 3 to the n over 2 to the n. So if you compare with this, are they greater than or less than? This one, this sign is greater than or less than? Which one's greater? The one in green is greater or the one in red is greater? Green, because the denominator is going to subtract, right? Make that whole fraction bigger. Is that okay? So make that whole fraction bigger. So this will actually be greater. Then you're like, well, that's not the same setup as before. Then you say, okay, well, it's got to be other things. So we just go ahead and take the summation of this one. But we know summation of this one is what? I'm going to ask Rebov, what kind of series is this? He's going to guess.
No, hold on. Let me cook.
I'll let you cook.
Is it?
Did you do like limit test?
Not yet.
Yeah. Okay. Is it just?
What did the two numbers have in common?
N.
So what can you do with that? Very helpful.
Did your exponent rules with one?
Dude, I forgot. Dude.
3 over 2 to the n.
Oh, okay.
Homework, like, when it asks us
We have homework?
to do, yeah, sorry. When it asks us to do a certain test, it has to apply, right?
You got to learn how to use it.
You did check for another no science thing or you want?
I'll take it to them.
You take it to you.
I'll take it to them.
I'll take it to you.
No, I will take it to the Orlando Science. I will take the check to Orlando Science. Okay, so this is 3 over 2, right? So 3 over 2 is greater than 1 because greater than 1. So therefore, is diverge serious? Because this one just multiplied by 3 over 2, multiplied by 3 over 2. But every time you multiply 3 over 2, the number gets bigger and bigger, and you adding those number is going to go to infinite. Does that make sense?
So what series is this?
This is geometric. So this is geometric
Wait, how is it geometric? It's like a different.
because this is R.
Yeah, but it's like different from the one that you wrote when you were talking about geometric.
This one is also geometric because I can change that to
Oh.
1 over 2 to the n, because 1 to the n is same thing is 1 over n. Is that okay? It's R is less than 1 because you multiply some number over and over and over again. Is that okay? So now this is it, and this 3 over 2 is greater than 1, diverge. So therefore, if this is diverge, and this is greater than diverge, what does that mean? Diverge, because you are you're better than Michael Jordan. If you're better than Michael Jordan, you has to be diverge. Does that make sense? So due to direct comparison test, so it's DCT, direct comparison test, ... The direct comparison test, summation of 3 to the n over 2 to the n minus 4, n equal to 1 infinity, is equal to is equal to diverge also diverge, because the other ones diverge. This is bigger than that diverge, so it has to be diverge. You cannot just say diverge. Yeah, write down DCT because I don't want to read more than I have to. Huh? AP exam, they do the same thing. Even on scored guideline, they say DCT, LCT, ACT. They write down, they didn't even write down the whole thing. Does that make sense? Now, what happened if you have this one? Now, like I say, this one you can also do a different way. You don't have to do it this way. If you were smart, you can actually do n-term divergent test, right? What do you mean by n-term divergent test? Is just take this sequence and reach infinity. If we reach a number, then it's the automatic diverge. Obviously, by looking at it, it reaches a number, but as of right now, it's infinity over infinity with indeterminate, which is you gotta take a derivative, which is will be natural log of 3 times 3 to the n over natural log of 2 times 2 to the n, limit n approaching infinity, and that's natural log of 3 over natural log of 2, limit n approaching infinity of 3 over 2 to the n. Obviously, this is going to go to a number, and if it's going to a number, it's not 0, so therefore automatically diverge, because due to diverge test. Now you can use n-term diverge test, but on the homework it's going to be specific for you. You have to use which one. Is that okay? Now I'm going to go to the next one. The next one says, hey, what happened if you got summation of n equal to 1 of infinite 1 over square root n plus 1. This one's interesting. Actually, this one has a second way to do it. I didn't mention last period.
Does it diverge?
What depends? What you compare with?
But I said like 1 over square root n.
Okay, but the problem of that is this: 0 less than 1 over square root n plus 1. And that's true, 1 over square root n. That is true, right? So I do a summation of 1 over square root n. Now here's the question I'm going to ask you. Which kind of series is this? No, n term is going to be, well, n term is going to be, yeah, n term is going to go to 0. So it's not 100%, it's not 100% sure it's divergent, but it's not n term. So you had to know the test. You didn't do that last two homework, I can tell from here. What kind of series is this?
Oh, PC.
Good job. See, you were smart. And you go to 1, infinity 1 over n to the 1/2. Since the p is less than 1, right? P is less than 1, so is diverge. However, if this is diverge and this is less than diverge, the problem is I can say I'm less than Michael Jordan, as well as Kobe Bryant can say I'm less than Michael Jordan. The problem is I suck. Kobe Bryant's great. Or even LeBron James can say I'm less than Michael Jordan. Or even like, I don't know, Stephen Curry. You can say I'm less than Michael Jordan. Right? So it can be two possibilities. It does not conclude that I'm diverge or converge in this specific case. Does that make sense? So if I use direct comparison test, it can be done though. It can be done, but I'm not going to go do that because I'd rather introduce your new test. But it can be done by using direct comparison test. But I won't want to in here because I want to introduce your new test. It can be done. It can be done. The reason why it can be done is, you can think about other situations. So I want you to think about if it can be done, what would you do to compare with, right? So therefore, let you know this is diverge. Pretty interesting one. So it can be done. I didn't cover last period, but I'll probably cover at end. But right now, if I have time. So I'd rather go to the next test. So the next test says, the next test is going to be purple, which is this one's kind of hard to understand. I think most of the people have problem with this test last period. Lemon comparison test. Suppose, imagine that, hey, I compare with that a to the n greater than 0 and b to the n is greater than 0 and limit as n approach infinity of an over bn is equal to L, where L is finite and positive. Remember, I didn't say 0. It's finite and positive. So finite and positive. So it could be 1, could be 2, or 3, or 4. Then, what did I tell you is the series you compare with, both a to the n and b to the n either both converge or both diverge. So they are both diverge or both converge. Let's just say this. if I take a Michael Jordan skill divided by my skill, that's not gonna be a finite positive number. Does that make sense? It's gonna be infinitely large. There's no way in hell I can ever be it. Right? It's infinite amount of number. It's not gonna be finite. But if you take Kobe Bryant and you divide it by LeBron James, oh, now we're talking, because that's gonna be a finite number. Maybe you can say Kobe Bryant is 5% better than LeBron James, right? That's a finite number. Does that make sense? If you compare that, and you say if it approach infinity, if you compare that, it becomes a actual finite number. So all the NBA player, even you compare Michael Jordan, the worst NBA player, right? Let's just say NBA player is all diverge. You take the Michael Jordan compared to that, it can says, oh, Michael Jordan is, 100 times better than Luke Longley. No, you guys don't know who's Luke Longley.
He was good. He played. He had what, like 3, 5 rings.
he's all right, but he's the shitty as hell. Compared to all the center in the whole NBA, he's probably one of the. He did his thing. He did his thing.
That's a bad example.
Even you compare to the worst NBA player, he can be factor. It can be like 100 times better, right? Michael Jordan is 100 times better than, I don't know, Muggsy Bogues, right? Yeah, you can compare. You can say that. That is still a finite number. But compared to me, a non-NBA player, they're infinite larger. Okay, that's just no way. Okay, so they both either converge or they both diverge. So let's try this. And because due to this, it's inconclusive. Do you understand why it's inconclusive? Reebok, do you understand why it's inconclusive? This is diverge. You're right. This is diverge. But this is less than diverge. So is a lot of people. A lot of people is less than Michael Jordan. But some people are great. Some people are not great.
Wait, so we're only looking for converge or diverge, right?
Yeah.
So then why isn't that just diverge? It's
no, because what if that's me?
Then you're also diverge, right?
No. It doesn't mean I'm less than Michael Jordan, I'm automatically great. I could be great. I could be suck.
So there's 2 different kinds of like diverge.
Well, diverge. Just think about all the NBA players diverge, right?
Okay.
So
all of them?
Yeah, all of them are diverge. Just assume that this all diverge, right? That's the cutoff line. NBA is diverge, right? There are people like Shaquille O'Neal, Kobe Bryant, Penny Hardaway, whatever. They all diverge. But so automatically, any of those players can say, I'm less than Michael Jordan. But they still diverge. But so is me. I can say the same thing too. I can say I'm less than Michael Jordan. But am I great? No. I can never be diverge. I can't even be a G Leaguer. I can't even be a high schooler. I can't even be Jarrett or Rebuff. How am I gonna beat? And there's no way. There's no comparison. No offense to you guys, but just the truth. There is no way I can compare to those people, so there's no way. Only 324 player in NBA player, right? 324? I don't know. 324 player are the greatest of the world. They are infinite better than us. The worst NBA player, they can beat you 15-0. No doubt.
Okay.
If they have the ball first, of course.
So I feel like we're getting lost in the metaphor here. My main concern, like, if it's less than diverge, doesn't that just automatically make it converge?
No. So if I'm less than Michael Jordan, so it's like Penny Hardaway is less than Michael Jordan, but he's an NBA player. He's also diverge as well. So it could be possible 2 things. So if I have less money than Bill Gates. Am I a billionaire? No. Right? But so is I don't know, other millionaire person are less than.
So if billionaire means infinity, right?
Yeah.
And 1 over n square root n is a billionaire, right? It's
No, it can be billionaire, it could be millionaire, it could be like me, teacher salary.
Well, okay,
But even
talking
if
about
that
the right,
works.
talking about the right. So 1/square root n is billionaire.
Okay.
Yeah, because that's one over square root n is diverge. We'll say diverge is billionaire, right?
Uh-huh.
And but the middle one, it could also be a billionaire, or it could be a teacher.
Okay.
Yeah.
All right. The basketball stuff doesn't work for me. The money that makes
Okay,
sense.
finance. I'm sorry. It's always about money, right? Money talks. All right, so that's the comparison. So let's come up with one. So we have this one, we are inconclusive. 1 over square root n plus 1 is less than 1 over square root n. It's true, but DCT fail. Is inconclusive. But try LCT. What is LCT? Well, we compare this to this. We divide this. So limits as n approach infinity of 1 over square root n plus 1 over 1 over square root n. So if you take, let's say, for example, 1 over square root n is Michael Jordan, and or 1 over square root n plus 1 over 1 over square root n. You compare that. Are they positive and finite? That's the things that you want to think about. Are they positive or finite? Okay, so we compare this. Are they positive or finite? So we can take this and we can say limit n approach infinity 1 over square root n plus 1. It's just a root algebra. We keep change flip, so it'll be limit n approach infinity of square root n over square root n plus 1. And I do that on purpose because I can do divided by square root n here, divided by square root n, divided by highest degree of the denominator. This is going to be limit n approach infinity 1 over 1 plus 1 over square root n. If it reach infinity, this one is going to go 0, but everything else is going to be 1. Since it's 1, and we know summation of 1 over square root n, n equal to 1, infinity, is diverge due to P series. Therefore, 1 over square root n plus 1 summation of n equal to 1 infinity is also diverge. Also diverge. Now we're going to talk about last one.
Wait, how did you, for the limit and approaches infinity, did you divide 1 by square root n? I thought it was supposed to be just n because it's outside of the square root.
No, I divided by square root n top and bottom equally. Okay, the last case I'm going to just show you here because I don't want to write down because we don't have time. The last case is we are comparing this. We are saying this diverge or converge? It looks very massive, look disgusting. If this case is true, then what I'm gonna do is I don't need to worry about anything this. This is a non-relevant. Why is this non-relevant? Because if it's going to infinite, the highest power decide wins. Okay. Highest powers win. So what I'm gonna do is I'm gonna just take the highest power here, and I'm gonna simplify it. And by simplify, I get 1 over n to the 3 over 2. This is on the video, by the way. So what I'm gonna do is I know this series is what? Is that converge or diverge? Converge due to what? P series, because P is greater than 1. So what I'm going to do is I'm going to take this and divide it by this. Do you see that? if I divide it by that, and I do my math correctly, which is everybody in this room can do math correctly, I'm gonna get to here, I'm gonna equal to 2. 2 over 2. So if it's equal to 2 over 2, it's 1. So therefore, the series also converge. Wait, is Matthew here? He left? Was he here today?
Oh, you're gonna have every single VC hit.
Isn't Matthew kind of quiet?